The next one to discuss is actually malware family. Three different pieces of malware have appeared with the names Duqu, Flame, and Gauss, but I discuss them here together because they have a similar purpose, and they exhibit many similarities as well. So Duqu, Flame, and Gauss is a malware family targeting critical infrastructure, but I have them here because they share similarity with Stuxnet in the way they propagate, how the code looks like, and also the digital certificates they used in order to establish connection. Unlike Stuxnet, though, there's nothing about the OT part. There's nothing about operational technology. The purpose was not destructive. Stuxnet was trying to destroy centrifuges. Here it was again all about information extraction, data exfiltration. So here the family was focusing on exfiltration from keystrokes, microphone, web cameras, image geolocation, password, cookies, anything they could find. Again, in critical infrastructure computers, they would extract and send back to the attackers. So even though there was no code related to industrial control systems, the code was written in a way that it was modular. So you could plug in something that would let you actually have an OT part in the malware, but that was not present in any of these pieces of malware. So in a way, the malware, this piece of malware could have been, before Stuxnet, right, could have been used in order to collect enough information to mount a Stuxnet attack. Or it could have been used to enable a future attack, because you collect information, you know the exact types of PLCs, you know the exact type of firmware you have, versions of firmware, you know configurations, you know industrial protocols. So you can use the information to have a real attack, an OT attack, a critical infrastructure attack affecting a process in the near future. In terms of attribution, the complexity of the code implies that they were backed by nation states. So these were very advanced pieces of malware that we don't think they could have been written by individual cyber criminals. And there was it was no clear financial motive, right? There was no, for example, ransomware or something else. It was just getting data out from critical infrastructure. So attribution here that most likely there were nation states behind that malware. So here again, as we've been discussing with all the incidents, the attacker type, we believe it's nation state, but the attack type is clearly an IT attack because there was nothing on the OT side. So if you did proper cybersecurity practice in the IT world, in your enterprise network, you could have prevented against these attacks. Next is an incident called Shamoon, and Shamoon affected Saudi Aramco in Saudi Arabia. Saudi Aramco is an oil and gas company, and it was targeted in 2012 through probably a phishing attack that we don't know exactly when it started. But what has been done is through the phishing attack, the attackers established a presence in the enterprise network, and then through the internal Saudi Aramco PCs, they could propagate to the rest of the network. And at some point, there was some kind of a time bomb that was activated, and it started the Windows-based computers, as this piece of text says here on the bottom of the slide. The Windows-based computers shutting down and being wiped. So they would start deleting their own file system, their own files, and then they would become inaccessible. After the attack, also Saudi Aramco disconnected from the world, and that happened around 2012. So in terms of attribution, again, this was more of an IT attack as well, because there was nothing affected the production environment of Saudi Aramco, the petroleum refinement or other processes. So it was mostly affecting the enterprise computers. But of course, as we can understand, even if only the enterprise, the business world is affected, this affects also the production itself, right? Because you also have to, you don't have business continuity. You have to shut down production to see what's happening, to make sure that you don't have an attack in your OT network, OT side as well. So here, in terms of attribution, hacktivists claim responsibility for the attack. There was a message, as you can see on the slide, there was a message on Pastebin that the hacktivists They posted the credentials of the CEO, like the email and the password. They also pointed out the router passwords, the core one, the backup, and the middle one used in the company. So they gave enough information to give credibility to the claim that they did the attack. And a thing to notice here, and on behalf of the attackers, is that even though there were some security controls in place, like McAfee or FireEye or Cisco ASA, all of these appliances had default passwords. And this goes back to the discussion we had about human error in the process of the cyber attacks and the misconfiguration, right? Default passwords is a major problem. The fact that we install the device and say, okay, now we have security, right? But nobody bothers to change the default password. So if you don't do that, then the first thing the attackers would try would be the default password. And here they managed to actually get through the systems, all the security systems, with using the default password. So as we said here, the attacker type was hacktivists, individuals that didn't need to have like many resources, right? They just assumed certain things, for example, default passwords and bad security practices. And the type of the attack was an IT attack because they mostly stayed in the enterprise network and the Windows computers. The next case I would like to discuss is the Target data breach. And while Target, the grocery store, supermarket, is not exactly what we think as conventional critical infrastructure, it's important to discuss it because this is the first known attack that the attackers went from the actual automation system to the IT world. So they used the HVAC system. HVAC stands for heating, ventilation, and air conditioning. So the attackers targeted the HVAC system, they took control over it, and then they jumped from the HVAC to the IT system to steal credit card numbers, customer information, the data, generally anything that the IT world, the enterprise network of Target had. So the total cost of the attack was estimated to be around $300 million, and more than 40 million debit and credit card accounts were exposed. This is an important attack to know because this shows how a system can be attacked through its secondary systems. So here, maybe the IT world of Target could have done a great job in securing the network, their own network, right? But they were connected to the HVAC system to be able to see how the air conditioning works, the air filtration, and so on and so forth. And that system had connection to the IT world that also was connected to the database. But the vendors may not have done a good job in protecting the HVAC system from cyber attacks. And that's what this is what the attackers used to get into the system. So the lesson learned here is that we also have to think about any secondary system we might have when we're trying to protect our own system, right? Even though the focus here was on the IT side, make sure that the customer data wouldn't be leaked. The attack came from a secondary system, in this case, the heating, ventilation, and air conditioning. You can think of a similar example in the pharmaceutical domain. If you want to attack the drug generation process, how drugs are being developed or actually manufactured to be sold, if you can attack the printers, for example, that print the labels for the drugs, then you cannot have the production going, right? So you kind of affect the production again by attacking secondary systems like the printers. Or in California was an incident that in a power grid substations, individuals started shooting the air conditioning systems from a distance, and by shutting down the air conditioning system, they managed to cause a disruption in the process there. So the Target attack, the attackers here clearly had financial motives. So it was they were most probably cyber criminals. And the attack was purely IT because they were trying to get information out. But what's interesting about this specific incident is that they use a control system to get into the IT world, and we typically see the other way around. So that the attackers use the IT system to get into the control world. Next is an incident that happened in New York, in Rye Brook, and a dam that's shown in the photo. So around 2013, the US Justice Department announced that hackers tried to access the control system of a small dam, the U.S. Justice Department specifically said that the hackers were probably of Iranian origin. And what the attackers managed to do, I mean, they didn't manage to do many things, right? They accessed, but because coincidentally, during the time there was ongoing maintenance, you couldn't remotely control parts of the dam. It was only monitoring was only possible. So here we had another remote access incident. Here the control system of the dam was connected to the internet via cellular modem. So you would connect to the internet in order to remote access it and have monitoring and control over it. So the attackers managed to obtain information about the dam, like water levels, temperature, and status of the gate, but they couldn't do more than that because, again, due to maintenance, there was no control possible but monitoring. That's another incident that we see the remote communication being an issue. And here, it was less sophisticated than the Maruzzi one we saw earlier, that someone had to know exactly how the SCADA communication in the RF side worked. Here it's just something connected on the internet. So anyone with an internet connection and the information, maybe random guess or lucky guess about what can be in that IP, managed to get access to that, and they would have been able to cause some more damage if, again, coincidentally, the dam wasn't under maintenance. So this case, the attacker it seemed to be nation state, even though it was not sophisticated, but there was attribution on behalf of the United States, mostly based on motive. Because if you also see at the timeline, 2013 follows the attack, the Stuxnet attack. So based on potential motive of attackers, there was the attribution to a nation state. The attack was clearly OT because they accessed the control system of the dam in order to get information. So it was directly a control system attack. Next is another malware family under two names, Havex and Dragonfly. We've seen both terms appearing in the literature. This family first appeared around 2013, and it was mainly attacks on energy grid operators, electricity generation firms, and petroleum pipeline operators. So that reminds us of what happened with Duqu, Flame, and Gauss, but here, unlike the previous pieces of malware, this malware had an OPC module. So OPC stands for Open Platform Communication, and this module was scanning for industrial devices. So the previous, up to Havex and Dragonfly, the malware that was mostly focused on reconnaissance did not have anything to do with the industrial world. But here, since 2013, we see automated malware doing reconnaissance with knowledge of control systems. So here the OPC was sending messages on TCP through the OPC platform. So it was TCP on ports 44818, 105, and 502 that are known industrial protocols on those ports. So again, we have reconnaissance-based malware, but here they directly go after industrial networks, and they try to map them, to understand them, and see what kind of devices are connected to the networks. Again, probably as a predecessor to a later operation technology attack. So here, the attackers, again, we don't know much, but a guess would be that this is sophisticated code, and it was mostly focused on reconnaissance. So if it's reconnaissance only, we would think, okay, probably not cyber criminals because they don't make directly money out of it, right? But there's sophisticated code. So sophistication points to nation states, and the attack was, I have in the slide IT and OT together because it stayed in the digital world only, right? It didn't affect part of the process, but it was process aware. It knew that there could be industrial systems connected, so it had industrial knowledge, and it was communicating with industrial protocols to collect information. So it was both an IT-OT attack. It was purely digital, but it was OT aware, operation technology aware. Next to discuss is German steel mill. We don't know names or locations. We know it happened in Germany because there was a press release on behalf of the German authorities on this cyber attack. And what the report mentioned, in 2014, there was a spear phishing campaign aimed at particular individuals in the company in order to open malicious documents. So after the documents were opened, then the attackers managed to get access to the enterprise network, and through the networks, the attackers moved to production systems, causing accumulation of breakdowns of components of the control system. Here we have an example of a stove control, the HMI part of it. So what the attackers managed to do, they managed to change different parts of the control system, so the furnace itself was unable to be shut down properly through following the proper steps to shut down, and that led to unexpected physical condition leading to massive damage to the system, again per the report of the authorities. So it was clearly an attack that affected the OT side, but in terms of who were the attackers, there hasn't been any confidence in attribution currently. So the attack was sophisticated, but not extremely sophisticated to the point that it could point to nation state, because there was not much malware, there was no malware involved. It was a spear phishing campaign that could have been done by less resourceful individuals. On the other hand, there was no one assuming responsibility for the attack. So we still don't know exactly what happened and who did it. The only thing that was published in that report was that it was mechanical failures and mechanical damage to the process. It was clearly not the attack, but the attacker was never identified. Next, another incident that we'll discuss also in the case studies of the class is a series of attacks on the Ukraine power grid. And actually there were two attacks. The first one happened 2015, close to Christmas. And what happened is the attackers managed to shut down 30 substations, and as a result, more than 200,000 people were left without electricity for up to 6 hours. So during the attack, the control equipment was rendered inoperable because the operators could not access the substations remotely, as the attackers managed to corrupt the firmware of the modems, the serial to Ethernet modems. So in order to restore power, the restoration had to happen manually. Again, a problem of remote communication, and since you don't have remote communication anymore, you have to physically go to the location to be able to control the equipment. So during the attack, before the attack actually, the attackers extracted the VPN credentials needed to connect the substation control systems. So again, we have a remote station, we need to connect to it. To connect to it, there was some remote connection through VPN, but it was a single point of failure, right? Because if you lose the credentials, then someone can connect to it. So probably there was no two-factor authentication where you have a secondary control, not only your password, but also some kind of a secondary mechanism for ensuring that the right person is accessing the systems. Extracting information can be done in many ways. We mainly suspect spear phishing again, that were suspicious documents sent to individuals, that when they opened them, the attackers managed to get access to the computer, and then through a keylogger or other mechanism, they found the password of the VPN connection. The attack was sophisticated because at the same time, in order to understand, for an operator, in order to understand where the shutdown is happening, where you have who has been affected, since they didn't have remote access to understand what is on and what is off, sometimes you rely on people calling and mentioning the problems. So if they were calling from some region and saying, hey, we don't have power, then the operators would know where to go to restore power. But the attack was sophisticated enough to have also fake calls to the call center of the utility. It was just spam calls, right? The robocalls, like automated calls from foreign phone numbers, interfering with the reporting efforts. And all these pieces, they really hint that behind the attack was a nation state. So that was 2015. A year after, we had a similar incident, but it was both similar and very different. It was similar in a sense that we had, again, a shutdown. Some part of Kiev here a year after went dark for an hour, so actually it was less time, But what's different here, even though the effects seem to be smaller, here the second attack was fully automated, right? So previously there were individuals trying to get credentials, and then they all logged in on Christmas Eve, and they tried to turn off substation at the same time. But on the second attack, a year after, the attack was fully automated, and that's much more scary now. Because, well, the name of this piece of malware has appeared with two names in the literature, either Crash, Override, or Indestroyer. So here we have a piece of malware that it has, again, a command and control capability, a launcher, and some kind of other mechanism, but then the execution of it has payload for different protocols used in the energy industry. So it has different payloads according to the traffic it can identify in the network. So this way, this can be automated, right? It can spread out to all computers, and when it finds something related to the power grid, it can turn it off based on some kind of a time bomb or some other command it can receive from its own control center. But as I mentioned before, we'll discuss this attack in detail in the case studies of the course. So this attack, because of its sophistication, was clearly a nation-state attack, and of course, it directly affected the operation technology environment of the utility. The last one to discuss today is Triton, and the name comes from the Triconex system of Saudi Electric that was affecting this attack. So in 2017, in a Saudi Arabia petrochemical plant, they identified that piece of malware targeting Schneider Electric's Triconex safety instrumented system. So that system is on the safety side, right? To make sure that if something happens in the operation technology part, that there could be a process of proper shutdown, of proper alerts, of proper controlling safety to make sure that there's no human injury, human loss of life, or damage to the process itself. So here, this malware was very sophisticated because it was using a vulnerability in the Schneider Electric system in order to modify the firmware. It was changing the firmware to install a backdoor. That backdoor was giving unlimited access to the attackers. So it was modifying the firmware to enable some kind of listening port to the network connection, and the attacker was able to send custom code on demand in order to do whatever they wanted. So they were sending special crafted network packets, and the system would receive the packets and respond to them, and they could disable the safety systems, they would disable the alarms, and in a way, because this malware was programmed to disable, inhibit, or modify the ability of the process to fail safely, it was very dangerous, right? Because it could have led to massive damage, massive destruction, because the process wouldn't be able to be stopped in a controlled way. So this is one of the most dangerous pieces of malware we have seen in critical infrastructure. And that's another case we'll discuss in detail in the case studies. Again, it's not clear what happened. The speculation is that the hackers found their way, again, through the enterprise network, and they managed to go through somehow through the DMZ from level 4 to level 3. They found a hole through the digital firewall, and they accessed the OT environment. So once in the OT environment, they found a zero-day vulnerability in the firmware of Triconex, and they used that to modify the firmware and add their own backdoor. And again, the attack is very sophisticated, and the fact that it propagated very quickly, it showed that the attackers also had pre-tested it in an environment that had a real hardware with a firmware to find the vulnerability and then to also exploit it. So all this sophistication points to, again, a nation state, and now the attack is clearly also an operation technology attack. And with this, we'll conclude the historical incidents, and things we noticed so far is, first, there's an increase in sophistication of the attacks. The sophistication are much more, it's increased, the attacks are much more targeted. We see now industrial protocols in the malware. We see direct access to firmware in the operation technology world. So we have increased sophistication and we have increased in the OT specific attacks, because around 2012, 13, 14, most of the malware was targeting only the IT side of the operation technology, but recently we've seen a great increase in attacks specifically targeting the operation technology environment.